Okay, let us get into the today's topic by understanding the simulation. You may see three dots moving from Mary's device to Jack's device, isn't it? Which means informations from Mary's device has to pass through certain devices like switches, network devices in metro area networks like that. Then what is the arrowhead says? That's what we are going to see today. That is transmission medium, and it has certain components like sender, receiver and intermediate area. So things which carries the information and passes from sender to receiver is said to be the transmission medium. Actually this process taken care by the physical layer of the 7-layer approach of OSI. Transmission media is classified into two major parts. One is guided, another one is unguided. Otherwise we can call it as wired or wireless medium. Under wired medium we have certain cable types like twisted pair, coaxial and fiber optic, which uses material and physical laying of cable is there. In unguided wireless media we don't lay any cable like of thing. Instead of we use some wireless devices that considered by radio wave, microwave and infrared wave. First we will see the guided media and its type. The one in the left hand side is a coaxial cable which use some copper or aluminum material inside. The second one is the twisted pair that uses copper always. The third one uses optical fiber as a transmission medium, and optical source and light beams are used to transmit informations. The limitation of three cables are depending upon the material property and the conductivity and the distance. Normally coaxial cable and twisted pair cable supports 100 to 200 meters, whereas fiber optic supports more than a kilometers. That is why we use optical fiber for long distance. For shorter distance we use twisted pair and coaxial cable. Twisted pair cable normally used in our laboratory and small kind of networks. This is a clear picture of twisted pair cable. We have 8 wires with different colors. For example, orange cable, and another cable is white cable with orange stripe, green cable and white cable with green stripe, blue cable and white cable with blue stripe, brown cable and white cable with brown stripe. Each of them twisted individually, that is why we call this cable type as twisted pair. These 8 wires are insulated by a tear rope. It is paper kind of thing, we can tear it off while laying and connecting the connectors. And this entire thing is cascaded inside the woven mesh shield, which is a protecting mesh, and over which we have a high quality PVC which protects the entire cable. Twisted pair cables are available in two types. One is STP, another one is UTP. STP means shielded twisted pair, UTP means unshielded twisted pair. There is no difference inside the cable like material or inner insulation. The difference is the outer shield with its thick material, where the STP uses the outer shield as a thick material. That's why that cable normally thicker than the UTP. The purpose of UTP and STP is UTP is used in interior cabling and STP is used in exterior cabling. This is a core switch and we laid many cables of UTP and getting connected to the switch, and we have a proper laying of cable. So this method of laying cable is called structured cabling. This has cascading and grouping and tagging and so many things comes under this structured cabling. Once we set laying of cable, we need connectors at its end. So how we connect this connectors at its end? We need a tool. In UTP cabling we need a crimping tool which used to crimp or make the connector firmly fixed at the end of the UTP cable, right? The connectors which we used in UTP or STP is said to be RJ45 connectors. The IEE standard is RJ45 connector. While crimping the connectors at its end, we have to follow some color code. That color code methodology is classified into two types, that is category A and category B. Usually this category A is the EIA568A and category B would be EIA568B of IEEE standard. So you can see the cable from 1 to 8. We have color code starting from green pair and orange and blue pair and again orange and lastly brown pair. So this is reversible in EIA 568B, like orange pair first, then green and blue pair, then green and brown pair. So that orange pair is replaced with green pair. That is the main difference between these two cable types. Normally category B types we are following, that is Europe countries following this category B, and category is followed in US standard or some other standards. We have two types of cable based on its usage. One is straight through cable, another one is crossover cable. The straight through cable, otherwise called a patch cable, which runs from your PC to your switch. Crossover cable is a special cable for a special device. If you want to connect a router directly to your PC, then you can use this crossover cable. So one more advantage is that crossover cable doesn't require any third device or sharing device. Same way, it is restricted to connect only two machines. For example, you can connect two PCs but laying up this cable alone. But straight through cable need a special device or centralized device like a hub or switch, right? The second cable type is coaxial cable. You can see this structure of this coaxial cable, which has a center conductor, maybe a single wire or multiple wire, over which we have an insulator and over which we have a outer conductor. Normally a mesh kind of thing is there. The materials used for this center conductor and outer conductor may be aluminum or copper. Copper is the best for communication, and entire thing is cascaded inside the jacket, that PVC material. So it has only two wires. One is inner wire, another one is outer wire. Probably you may see in your cable connection for your TV. Now we will see how the coaxial cables are connected with its connector. This cable connector is called BNC connector. One type is BNC male, another one is BNC female. This connector is connected at the end of the or termination of the each of the cable. There is no difference like crossover cable or straight cable, because we have only two lines, right? So only thing is it has a BNC male connector and BNC female connector. We can connect cable to cable directly. The right side one which we have is a patch cable of coaxial cable, which is shorter in distance. The third one in transmission media is the fiber optic cable. It is quite interesting. As you can see, a green laser light is in the side of the glass tube, which is reflected in its inner core and transmitted at its end. It is made up of fiber and the informations are in light. This is how optical cable is getting connected with its connector. The above one is showing the simulation and the below one has its own parts. The first one is fiber part, which is connected into a PVC case, which is a boot which has a flexible slots in its end. And the next one is a connector sub assembly, which is nothing but a lens kind of thing. At its termination, we have a dust cap because we have a light beam. Without disturbance, it has to reach the device. So we have a dust cap at its termination. This is how the optical cables are terminated or connected with its connector. It may have different types, round one or square one, depending upon the interface it has to reach. And another type is a PVC or metal case, threaded or non-threaded. We can just plug it in so that it automatically locks. In some kind of thing, we have to screw it to connect with the device. We know optical beams are used for transmission from source to destination. By using the optical beam, we classify that optical fiber cable into two types. One is single mode, another one is multi-mode. In single mode, we use only a single beam. In multi-mode, we have multiple beams. Multi-mode is further classified into two types. One is step index, another one is graded index. How the multiple laser beams are used, what is their property, how the angles are maintained. So these kind of things will classify this multi-mode into step index and graded index. The simulator shows how the single mode fiber is different from multi-mode fiber. First we will see this single mode fiber where we use a single red beam all in the straight line, but once it get into the fiber core, it is reflected to the surface and reflected again, and continuously do that reflected beams reach the destination. So these informations are single information from one end to another. In multi-mode, same as single mode, but the difference is we use multiple beams and with multiple angles. So only difference is a multiple beams are used in multiple mode fiber. So it is faster than the single mode fiber. There are a lot of information to discuss multi-mode fiber. That we have two types of classification. One is multi-mode step index, another one is multi-mode graded index. In multi-mode step index, we have cladding. Inside a fiber core is there, where the light beams are transmitted. The beams are not a single one, a multiple beams are produced with multiple angles. These beams are reflected by its wall, that is core wall, and maintains its angle until it reaches the destination. The beauty of this optical fiber cable is once you bend it with certain extent, it won't lose its light or light intensity, even its angle. In multi-mode graded index, same principle is followed, but the core is a different property where it deflects in its own core. So it maintains a parabolic kind of information, I mean parabolic kind of light beams inside the optical core. So this is a uniform deflection inside the core, so it can carry more number of data. As you can see in the right hand side simulation, it maintains multiple spherical parabolic transmission. Right? There is a uniformity. In angled method in step index, there is no uniformity. In graded index, the uniformity is maintained by the deflective material inside the optical core. Up to this, we discussed transmission media as a guided one. Now we are in wireless area where this unguided media is used. The property behind the unguided media is electromagnetic spectrum. Spectrum is nothing but a range of the wavelength usability. The below diagram shows starting from 3 kHz to 300 GHz is said to be radio wave and microwave. The first part would be the radio wave and the second part would be the microwave, which is inside the 3 kHz to 300 GHz. Starting from 301 GHz to 400 terahertz is infrared, and 401 terahertz to 900 terahertz is going to be light wave. The wave is different, and starting from 3 kilohertz the wave vibration is more, and at 900 terahertz the vibration is very low, like a light beam it transmitted. So this is the major difference between lower frequency and higher frequency. So with its higher frequency, lower frequency, there is a propagation methods. How we are connecting? We need a tower, we need a line of sight, we need a sky propagation, satellite or a reflection of ionosphere. So you may know, exterior to the global structure, we have LEO, MEO, GEO, like that. The kilometers from the ground level, we maintain some GEO, LEO, MEO, like that. So we have ionosphere, which is nearby this global structure, in which we have tower connectivity and satellite connectivity and so on. By this we classify these three types as ground propagation, sky propagation and line of sight propagation. In ground propagation we have below 2 MHz is used. In sky propagation we have to use 2 to 30 MHz. In line of sight propagation 30 MHz above. Why we need this thing? So distance is the matter here. So in ground propagation it supports and it needs repeated towers to transmit the detail because its power is less. In ionosphere somewhat greater than the ground propagation, and in ionosphere line side propagation it has more than 30 MHz. The first one is ground propagation. You may see towers, for example cell phone towers here and there. Actually they are the microwave towers which transmit the data as a microwave frequencies. It has a limitation, maybe 10 kilometers, 5 kilometers, 30 kilometers of range. And another antenna is said to be a parabolic dish antenna, and another one is a horn antenna. So these kind of antennas built for it attenuation. Attenuation means the receiving method, receiving reliability. So according to the usage we use these three types. Normally we use tower type of thing for ground propagation. If you want to connect one office to another office which is in the same city, you can use this ground propagation, which will not support more than 20 kilometers, 30 kilometers likewise. Next one is sky wave propagation or sky propagation, where we use antenna in high frequency which sends the signal to the ionosphere end, and it will be reflected from to ground and ground to ionosphere again. Likewise it reaches the receiving end. It requires high, very high frequency so that it can reach the destination. It supports more than 50 to 100 kilometers, but disturbance are more. The signal which drops to earth should be landed in a particular area. Otherwise there is no deflection, it won't reach the destination. All this system can be understood by an ecosystem. The ecosystem says a reflecting of the voice or reflecting of frequencies. Likewise this sky wave propagation reflected in between earth and ionosphere so as to reach the destination. This is the third propagation method, that is line of sight propagation, which maintains a straight line of connectivity, and of course it needs the straight line, otherwise the transmission will not taken into effect. In this picture, a right side tower is connected with left hand side tower and transmitted from right hand side to left hand side. There is a disturbance of triangle in between, so the loss of signal would be there. So we need a line of sight as its straight line. It is not absolute straight line, maybe there might be a deflection of 10 to 15 degree, not more than that. If it is more than 15 degree, it won't support. So we have a direction of fixing the tower, direction of fixing the antenna, and the height is the matter. If we have lot of disturbance in between, we have to maintain the height over the disturbance so that we have transmit the signal from one end to another end.